everyone. Very warm good morning to all. So, today, this is our second lecture in the webinar of 2 days international webinar, sorry, on Paleowords, History, Heritage, and Horizons. So, we have a very eminent scholar, Ashok Sahni, and we are very happy to have him on the platform of the history enthusiast. And thank you so much, sir, for accepting our invitation. I warmly welcome you to the platform of the history enthusiast, and we are very excited to listen to your talk. And I also take this opportunity to welcome our honorary president, Srinandan Shastri ji, and founder president, Ms. Manali Momaya, and principal of the Bangarama Sajjan College, Vijaypur, who have collaborated with us for this webinar, and Department of History faculties, Mr. Mallikarjun, and other faculties who will be who have collaborated with us, and all the students who will be joining us through this session. The morning session was a wonderful success with more than 600 views, and I thank all our audience for making it a successful session, and we hope the same response for this session too. Now I request Ms. Manali Momaya to introduce our today's second resource person, Mr. Ashok Sahani.
Thank you very much for the warm welcome, Nidhi. Our distinguished speaker, Professor Ashok Sahni, is a towering figure in Indian paleontology, someone who has literally put Indian dinosaurs on the world map. It is my privilege to introduce Sir, who is Professor Emeritus at Punjab University, Chandigarh. Professor Sahni began his academic journey at Lucknow University and went on to earn his PhD in geology from the University of Minnesota, USA in 1968. On his return to India, he served with great distinction at the universities of Lucknow and Chandigarh, inspiring generations of researchers and students. His contributions span continents and institutions, from the American Museum of Natural History in New York to the National Museum of Natural History in Washington, and as visiting professor at Bonn University, Germany. He has also played a pivotal role in UNESCO IGCP projects, both nationally and internationally. Professor Sahni is a fellow of all the Indian Science Academies and also holds memberships and fellowships in several prestigious global academies, including the Third World Academy of Sciences at Trieste, the Humboldt Foundation in Germany, and the Geological Society of France. His achievements have been recognized with some of the most prestigious honors in earth sciences: the INSA DN Wadia Medal, the National Geoscience Award for Lifetime Achievement, the Lifetime Achievement Award of the Electron Microscope Society of India, and most recently, the Lifetime Excellence Award of the Ministry of Earth Sciences in 2020. Beyond research and teaching, his vision has shaped public engagement with science. He has been consultant to the Evolution Park and Gallery at Science City, Kapurthala, and was instrumental in establishing the Dinosaur of India Gallery at the Chandigarh Government Museum. With such a rich and remarkable career, it is no wonder his talk today is titled Indian Dinosaurs, Dead but Doing Well. Please join me in extending a warm welcome to Professor Ashok Sahni. Sir, the stage is yours.
Thank you very much. Can I have the first slide, please?
Sure.
Hello.
Yes, it's on the screen.
Okay, thank you. So I'd like to thank the History Society for inviting me. It's a real pleasure for me actually to give this talk. I've given this on several occasions, but I thought that this would be another occasion, because paleontology basically is history of life on Earth. So I thought that maybe for people interested in history, I should speak about some kind of history. So I'll be speaking on Indian dinosaurs, dead but doing well. As you can see, and as you can see in the media today, there's a lot of information and media coverage of all types of information on dinosaurs. Here are three. The three big magazines of the world have on the cover page uh, something about dinosaurs. So even though the dinosaurs became extinct around 66 million, but as you can see, they're still around with us. They're on motifs of t-shirts and mugs and all kinds of things. So they're really doing well. Next slide, please. So can you change the slide, please? So since I'm talking to a history society, there are two persons actually who are historical figures. In fact, I recall that when I was studying history in school, there was this thing about who abolished Thuggy. So here is a picture of William Henry Sleeman. He's the person actually who finished the Thuggy in India. And it so happens that he was the first person to actually collect bones of dinosaurs even before they were identified as dinosaurs. He lived very close to the Jabalpur station. And if you've been to Jabalpur, there are some hills around there near the station. And he lived close by. And he was able to collect a number of dinosaurs and he sent them to the British Museum. So he is a historical character and also he did a lot for uh, finding dinosaurs in India. The next historical figure is Stephen Hislop. He did a lot of work in near Nagpur and in other parts close to Nagpur. Found a number of sites with bones and mollusks. Wrote them up in many articles, and he's still he's still there in the form that there's a college named after him, the Hislop College in Nagpur. So this is the history connection, with dinosaurs and dinosaur localities. Next, please. Next, please. So just to tell you a little bit about fossils. Fossils, basically, if you want to simply put a definition, they're the remains of past organisms. So here you can see uh, there are two fish, by the way. If you look at the first diagram, you'll see that there are two fish. The big fish is eating the small fish. I hope all of you can see that. The next one is something closer to India. So, in about 10 years ago, there was a big discovery where uh, raisin deposits in Gujarat yielded a number of ancient insects. So, this is one of the pictures from a field near Surat. You can see the insect beautifully preserved. All the bristles are there. Everything is preserved. And the third photograph is something that is very close to my heart. It's, I think, Chile or Peru or Bolivia, somewhere in South America. I want to modify the definition of a fossil. So, fossil, I said, remains of a past organism and their activity. So, even though you don't have the body fossil, you have signs of their activity. And here are two dinosaurs. You can see, walking side by side, up or down a area, which is basically a lake bed. And if you look at the arrow which I've shown, at that point, the right dinosaur has nudged the left dinosaur so that it has gone out of the path, the straight path where they were walking. So this also this is also a fossil. So fossil basically is remains of past organisms or of the activity. Next, please. Next, please. So just to give you a brief idea, you know, there would be no life if photosynthesis had not happened. If you look at the bottom axis, it's on a log scale. Uh, that gives basically years, million years. And around 2.2 million years, an event happened that actually changed the face of our Earth. And all that we see, the big animals, the small animals, the flying animals, they are the result of an event known as the Great Oxygen Event that happened around 2.2 million years ago. And after photosynthesis started at this point of time, oxygen started streaming into the atmosphere. And if you look at the vertical axis, you'll see that as time went on, the percentage of oxygen increased. Uh, so when it got around 40 to 50%, then high life forms evolved, including mammals, dinosaurs, and all the rest of it. So uh, the fact that you have life and you have activity, locomotion, uh, birds flying in the air, basically boils down to the fact that you have oxygen available in the atmosphere that allowed such activities. Next, please. Next, please. So, just to get one point straight, so all of you know that India was once part of something known as Gondwana land. So, India is right there in the middle here. This is around 66 million years, about the time that I'm talking to you about the Cretaceous dinosaurs. And you can see Madagascar, Africa, Antarctica, Australia. So the Indian dinosaurs and the Indian other animals actually have greater affinity to the Gondwana land countries rather than what you see right on the top of the screen, which is Asia. So many people ask, is T Rex available here? It's not available, but we have counterparts of T Rex, big carnivores that equal T Rex, uh, which have no relationship actually with T Rex, but they are very, very similar. But the Indian and the South American uh, and the Madagascar uh, dinosaurs are Gondwana dinosaurs. So this is one point I think that one should bear in mind. Next, please. Next, please. So, just a few slides just to get dinosaurs in the proper perspective. People actually, I think, are fascinated. One of the fascinations is that a fascination of size. They grew so big. So the thing is actually that if you're a land living animal, you have constraints. You have constraints that you have to, you're growing against gravity is pulling you down. You have bones. Bones are made of mineral matter. They're connected by cartilage. So there's a maximum weightage that you can actually perform biological functions and still walk around and still grow. So, in fact, dinosaurs achieved this. The maximum theoretical weight that can be supported on land is something like 70, 75 tons. Beyond that, the bones will buckle and it will not be able to perform, the animal will not be able to perform its biological functions. So, one of the fascinations is this that, they were able to grow to gigantic sizes. And I'll tell you the reason for that. Next, please. Next. So, so one of the things that one has to be clear that, of course, if you are a giant, Other animals will be afraid of you. That's one point. But there's a deeper meaning to this. And the deeper meaning is that if you are large, then you have more volume to surface area. Most dinosaurs, or in fact, nearly all dinosaurs, are cold blooded. So it's an advantage for cold blooded reptiles to be large. If they're large, then the internal organs are insulated against, excess heat, excess cold, whatever. So the size actually basically acts as a thermal insulation. And that is one of the advantages of being large. On the other hand, if you if you're small, so you have large dinosaurs and you have very, very small dinosaurs. So the very small dinosaurs have more surface area to volume, and therefore they are very susceptible to heat or cold or whatever is the temperature of the environment. So that's not a good idea for cold-blooded reptiles. If you're a cold-blooded reptile and you're heating and cooling at will, so it's not surprising that the small dinosaurs, and this is the reason, one of the reasons, they develop feathers. Feathers are very good insulation against you know temperature. And as you may know, and as I will show you, that the birds developed from very small dinosaurs. At one point of time, it's difficult to tell whether it's a feathered dinosaur or whether it's a bird. And this is one of the reasons that feathers developed actually to insulate the animal against uh, whatever be the ambient temperatures of its surroundings, because they were cold blooded. And this is one way to insulate them. Next, please. Next. So people think that dinosaurs don't have a heart. We all have to have hearts. But if you look in a uh, in a chart here, uh, the larger you have, for a cold-blooded reptile, you have to pump blood to extremities. So, so even if so, for humans we know, and for birds we know what the blood pressure is, but very few people know that the problems that dinosaurs had in large dinosaurs. So uh, the heart was very small. It's something like a fist size for an animal that big. And in order to do that, they developed a blood pressure that was about 5 or 6 times what is normal for us humans. But that is natural because you can't expect uh, blood to be fetched from the from the brains or from the end of the tail without that kind of pressure. So this is one aspect. Next, please. Next, please. So this is if you ever go to Chandigarh, this is it's a life size actually. This is a scale given at the base. It's 1 meter. We built this ourselves, and one of my students painted it. It's actually on a wall, and it gives you an idea of the internal organs of a female dinosaur. So people always look at dinosaurs; they're very ferocious, and they're just like any normal reptile. And so this is just to give you an idea that they're as normal a reptile as you can get. Next, please. Next, please. This is an old photograph, one of my favorites of uh, uh, of a dinosaur known as Barapasaurus tagorei. It was excavated by the Geological Study Unit of the Indian Statistical Institute in Kolkata. It took them 10 long years, but this is the first, and it's a magnificent mounted skeleton, the first ever in India, and now it's shifted to another building. But uh, uh, this actually gives you an idea of the scale. You have a fan and you have some lights, so you can get an idea of the scale. So this is Barapasaurus tagori. Next, please. This is just to show you, the that uh, how some of the Indian carnivorous dinosaurs they ambush their prey. Next, please. So coming back to a little bit of history, I've just mentioned Henry Sleeman, William Henry Sleeman, and as you can see that I told you about him, and there's a red star that you can see above the photograph. That's actually a village or a town, small town, named after him, very close to Jabalpur, not far north. And on the right hand side are the localities in India where you get dinosaurs. So there's, if you look at the top left hand side, that's one locality in Pakistan, but all the rest are in India. Right, starting from Gujarat all the way Rajasthan, Madhya Pradesh, Maharashtra, Andhra Pradesh, one in Meghalaya, and uh, two, three localities in South India at a place known as Aryalur. So in India, in Peninsular India, there's several localities where you get dinosaurs. Next, please. So people are now very familiar with a dinosaur that was described, I think, in 2003, Rajasaurus narvadensis. Uh, there was a officer of the Geological Survey of India, Suresh Srivastav, who was given the task of excavating uh, an area in what is now known as Balasinor. There's a big park there now. And in 1983, with great being very meticulous, he was able to plot all his excavated. This is actually a picture of the bones lying as they were excavated. The yellow pictures that you see out of all these bones are those that belong to Narmada. There's Rajasaurus. They're given in yellow. So a number of bones were excavated, but the bones that actually relate to the carnivorous dinosaurs have been colored in yellow. So it's not an easy task. Right? If you think that there was a huge skeleton out there, that's not the case. In most cases, when the animal dies, the bones are scattered. So it's the responsibility and the ability of a paleontologist to basically identify the bones and piece them together like a jigsaw puzzle. So when you see the skull of Rajasaurus, it's actually pieced together, and it's very similar to a similar dinosaur in Madagascar. So you may recall the photograph that I showed you, that India separated from Madagascar. So, but so they have the same kind of uh, dinosaurs in Madagascar that we have in India. Next, please. So this is another dinosaur which is located in Hyderabad, Kotasaurus, that was excavated and mounted by the Geological Survey It's also a magnificent uh, piece. And both of these, Kotasaurus and Parapasaurus, are from the Jurassic of Andhra Pradesh, something known as the Kota limestone. So, if you look at this image, you'll see that there are various stages. If you look at the bottom left, you'll see the bones lying, then the excavation, then the building of the frame on which these bones are being put, and then the ultimate skeleton. So it's a big, big process. To extract a bone from the rock may take weeks or even months, depending on how hard the rocks are. Next, please. So my special area, of course, is dinosaur nests and eggs. So as you can see from the top left-hand side, nearly mimicking the sites where you get the dinosaur bones, you get nests and eggs roughly in the same localities. So this is these are some eggs here. They're now in the Chandigarh Museum. In fact, when I retired, I donated most of my stuff to the museum, so they're there. But you can see that if you look at the right hand side, this is a typical nest of a large plant eating dinosaur. It has about 10 eggs, and they're laid the eggs are laid close to each other. So that itself is a feat because the mother drops the eggs from some height. It can't bend. It can't bend too much. So these are the nests in India. In fact, the Indian nests and eggs are one of the largest hatcheries known anywhere in the world. Yeah. So in other places you get eggs and you get nests, but not at this scale. Next, please. Next, please. So, my work actually relates to looking at the thin sections of the shells, because whether it's a lizard or whether it's a dinosaur or whether it's a crocodile, basically the embryo has to grow in the same way. It's not that dinosaurs had something special going on. So for any embryo to grow, you need provisions like a yolk, you need air. And if you look at, and this you might find interesting, if you look at the bottom left uh, section, basically it's like a radial section. If you look at the section, you'll see a white line. That white line actually is a canal. It's a canal that connects the inside of the egg to oxygen, the outside. So the embryo breathes normally. If there's no oxygen, it will die. And so even though the shell of these large dinosaur eggs may be something like 2 millimeters or so, they are sprinkled with pores and air canals so that the hatchling, the embryo, can get enough oxygen. Next, please, I'll show you in this. Next, please. Next. So you can see if you look at the right hand side, this is the example of an egg and what's happening. So the shell is very thick, and therefore for the embryo to breathe, for the hatchling to breathe, you need air canals. And if you look at the left, as I showed you before, you have air canals, and the one on top, the top left, the one with the rounded structures. If you look carefully, that is a tangential view. That you're you're taking a section from the top of the shell, and you'll see these small circular holes. So the whole shell of a dinosaur is pitted with these holes to allow the oxygen into into the egg. And one very interesting thing, that as the embryo grows, it uses the calcium from inside the shell to build its bones. That does two things: the bones get bigger and the shell becomes thinner. And so by the time that the embryo or hatchling is about to break the shell is very thin, and the hatchling occupies, as you can see from the top, most of the egg. So that's how nature works. Next, please. Next, please. So these are some other eggs. These are the eggs of the carnivorous dinosaurs. They're different. They're elongated, and as you may have heard or read somewhere, that the locals use these eggs to grind spices. They're actually perfect, you know. So there are many such cases that have been reported in the newspaper. Next, please. Next, please. So this is very interesting. There's something else that I've been doing, and that is this is actually a section of dinosaur dung or dinosaur poop. As you can see, it's full of leaves. It's full of leaves. It's got some stems. You look at the right, you'll see a stem-like structure. So we've been able to find a number of things inside dinosaur dung, which basically gives you an idea of what they ate and how the digestion took place. So that's another area of study. Next, please. Next, please. So coming back to closing this talk, there's two, three things. You know that there are two competing theories about how the dinosaurs became extinct. Before we look at the two competing theories, let me tell you one common factor between both the theories. The common factor between both the theories is that somehow the Earth has to lose contact with the sun for several weeks. And when that happens, then the food cycle actually changes, because after several weeks without the sun, uh, the plants decay. Now, I'm telling you this reason first, and then I will tell you what actually happens. So if you look, this is the basic concept, that dinosaurs and 65% of all life became extinct because the atmosphere was polluted. It was the sun was blacked out for several weeks. This kind of condition these days is known as a nuclear winter, and both the theories are dependent on the fact that the food web cycle was disrupted, and that caused uh, uh, that caused extinction, at least on land. Uh, in the sea, it was slightly different. Now, coming to the first, if you look at there are two hypotheses, as I said. If you look at the top left, the asteroid impact, so we have one in India. Top right, you look at Amravati, the one in Maharashtra. But the one that killed the the dinosaurs and 65% of all life was basically about it was estimated to be about 7, 8, 10 kilometers in diameter, and it happens like once every 100 million years. So that you get this big asteroid hitting the Earth. So as you can see in the top left, there are a number of sites given in red where the effect of the asteroid is seen, whether it's in the deep sea or whether it is on land. You have an element known as iridium, which is actually an element that is not found on Earth in that proportions, but it's very common in extraterrestrial uh, in extraterrestrial objects. So I won't go into that. Just to say that Alvarez and his son were able to establish that there's a critical iridium uh, uh, iridium rich in that sense, even though it is in nanograms, iridium rich area layer above which you don't get dinosaurs, below which you do. So, so that is the asteroid theory. The second one, of course, is volcanic eruptions. It so happens that it happened nearly at the same time. So there's always a, a contentious issue: asteroid or volcanic. But I think these days the asteroid impact has greater weightage, and the volcanic eruptions are believed to have caused the final blow as far as atmospheric pollution is concerned. Next, please. Next, please. So this is what actually happens. Look very carefully on in the bottom image. What actually happens is that when an asteroid strikes, the water evaporates, the rock evaporates, and the rock evaporates. It goes into the atmosphere and blocks sunlight. So if you look at the top right, this is actually which causes the the demise of forest and vegetation. There are other things like carbon dioxide, heating, and wildfires and all. Fine, but in order to succeed in destroying on a global basis, you need a global event. And that global event actually is believed to be this kind of blockage of the sun for several weeks. It's been estimated theoretically that if you block the earth from the sun for several weeks, then the vegetation will decay, it will not grow. So all animals that live on the vegetation and all animals that live on the animals that live on the vegetation will perish. So we come to the next slide. Next slide, please. So they finally found one place in America, North Dakota, where you get what is believed to be the actual remains of the last day of the dinosaurs. So you have a place known as Tanis, and which is shown on the top left. And there you can see you have uh, a number of fossils. That's actually a leg torn out of a dinosaur. This is a man who's actually studying it. And as I said, that what happens is when the rocks melt, they rain down as droplets known as microspherules, those rounded things there. And the fish found in this site are actually filled with these microspherules. So this is a site that you can check on the net. It's known as the Tanis site. And this La Palma actually believes that he has found the site that reflects how the tsunami waves reached internally into central North America. And then you got these forms. And the last two slides, I think. Next. Okay, so this is the alternative which I've talked about: the dinosaur, the Deccan traps, and the noxious gases that are actually go with the eruptions. Uh, Chlorine, sulfur dioxide, many carbon monoxide. So there's a lot of toxic gases. Next, please. Next, please. So coming to the last two slides, as I said, and I tried to explain, you have feathered dinosaurs on the right, and you have birds. There's very little difference at the start of, if you look at a skeleton of a feathered dinosaur or of a bird, you will not be able to make out. Both have teeth, but later on, birds develop wings, and they require special kind of anatomy. And the last slide, I think, uh, the last slide. Yeah, well, if you have not believed whatever I've said, maybe you will believe this. Thank you very much. Thank you. Thank you.
Thank you very much, sir, for the very interesting and engaging lecture. And as someone who has always been fascinated with uh, all kinds of dinosaurs, and somebody who has always wanted to study about dinosaurs, this lecture has been really very interesting for me. So thank you for that. I think there are some questions.
Yes, we have around 8 questions. With your permission, shall we take those, sir?
Yeah, go ahead.
Thank
So
you so
before
much.
I have already posted some questions, but before
There's
that,
an echo. There's an echo.
Uh,
There's an echo.
your voice is breaking, Manali.
There's an echo.
can you hear me now clearly?
No,
Uh,
your voice
a
is
little
still.
bit.
There is lot of disturbance in the background.
Oh,
Go ahead. Go ahead.
yeah, I just wanted to know which dinosaur would have been the closest in history uh, to human existence, like before human beings came on this planet, which was the dinosaur that was like latest.
No, they all died. They all died around 66 million. Human history starts around 6 million.
Yes.
There's no relationship between humans and dinosaurs. Dinosaurs all died around 66 million.
Yes.
In fact, there's a small primate known as Purgatorius that evolved just after the dinosaurs died. The oldest primate is Purgatorius, uh, uh, very close to uh, the time when these animals died. There were other mammals, but that's about the only connection.
Thank you, sir. Yes, Nidhi, you can take the questions.
Yes. Uh, the next question is by Chandini. Near Sydney in Yampi, here we also get egg fossils of dinosaurs. How is it? How can we preserve it, and how how it is preserved earlier? That is the question which Chandini has asked.
By preservation, you mean preservation in the field, or what?
I mean,
How
how have they been preserved for so long in that area?
Yeah, that may be the question which he's asking.
can you repeat the question? It's very blurred here.
Yeah, sure. Near Sydney in Yampi, Madhya Pradesh, here we also get egg fossils of dinosaurs. How are they preserved there?
How are eggs preserved? Well, that's a good question actually. So there are two ways. So if you look at eggs, wherever, whether it's Madhya Pradesh or wherever, there are some that where the hatchlings were able to hatch. That is, they were the embryos grew into hatchlings. They broke the shells. So so, but there's another case in which flood waters completely buried the nests that were laid, and those eggs and nests were the animal the babies died inside the eggs. So you have two kinds of conditions, both are preserved because, as I said, the mineral matter of the shell is calcium carbonate. So that's the mineral matter. So just like it's not soft parts, the internal parts are not present, but the shell is there. The shell is like it's made of calcite. It's a mineral known as calcite, and that is uh, a hard element which is preserved.
Thank you, sir. Thank you so much. So the next question is asked by our honorary president Nandan Shastri ji. The question is, one of the recent breakthroughs, feathered dinosaur tail conserved in amber. Uh, will you reply to me how amber preserves fossils? That is the question asked by him.
Well, that he's talking about the one in Burma, in Myanmar. In Myanmar, they were able to find, I think, the tail of a dinosaur, or part of the skull or something. So it's a raisin. Raisin exudes from trees when there is some attack on the trees. So if you were to cut a tree, then it will exude raisin. Or if there's some insect action, you will get raisin pouring out. And if you have a small dinosaur which is maybe as is dead underneath the tree where the raisin is oozing out, then the raisin will cover the cover the body, and the animal or plant or whatever it is will be preserved.
Thank you. So there is another question by Nandan Shastri ji. How do you compare the efficiency of a human brain with that of a dinosaur's brain?
No, actually, so there are a lot of jokes on this. So I don't think there's any comparison, for the simple reason that dinosaurs, because they're mostly cold-blooded, are more sluggish. They have a sluggish nervous systems, whereas human brains, as you know, uh, are not like that. So there's actually no comparison.
Thank you, sir. There are a few more questions by Manali. Manali, do you want to read them out?
Yeah, sure. So you began your presentation by highlighting William Stephen and Stephen Hislop's early
I
discoveries.
can't hear that. I can't hear you.
Uh,
Uh,
could I
so
read it?
can
Could I read it for you?
Yeah.
Okay.
yeah,
Uh,
please do.
Manali is trying to ask that you begin your lecture by highlighting William Sliman and Stephen Hislop's early discoveries. How do you see the role of colonial explorers and missionaries in shaping the history of paleontology in India? That's the question.
Well, I don't want to use the word, but it was basically loot. It was colonial loot. So they exploited uh, whatever they could find, and so many of the important fossils are not in India. They're in the British Museum. Yeah. So um, so the hard fact is this, that they did what they thought that they were doing, but it took a long time for Indians basically to do their own paleontology. That's the brutal fact.
Thank you, sir. And another question by Manali is
Am I audible? Am I audible?
yes, Manali, but again the voice is filled with a lot of disturbance. Well, I don't know why.
Okay, please read it. Yeah.
So should I read it for you?
Yes, please, please.
Okay. What insights into dino behavior or ecology have Indian dinosaur egg fossils and uh, coprolites revealed? Also, in your view, what is the most significant Indian dinosaur find to date and why? That's the question.
Uh, so basically the ecology. So 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 the nests give you an idea of where these eggs were laid. They were laid in actually interfluve soils. So they were laid very close in soils. Number one, uh, and most of these soils have, like today's conquer. The if you've heard of conquer soils, they were very rich in calcium carbonate. So we know that there was a preference, let us say, that a preference of dinosaurs for laying the eggs in fairly soft areas, because you must imagine that one egg, is about maybe 15 to 20 centimeters in diameter. It's filled with liquid, and it falls from something like half a meter. So the material is very, if the ground is very hard, it will break. So I think the mothers chose the area very carefully, in soft sand, in soft soil, maybe close to a sandy place where the eggs would not break. That's one point. The other point, I don't know what was that. What was the question? The last question. One was on ecology, and the other one was as far as coprolites are concerned. It tells you what they ate. So what they ate were actually. Uh, have you heard of the plant Araucaria? It's still around. So they ate leaves of Araucaria. They ate small cones, because that's also found in the coprolite, seeds, small twigs, that kind of thing. Okay.
The second part of the question was, what is the most
I,
significant
I didn't hear.
Indian?
And
Oh,
uh, what is the most significant Indian dinosaur find to date and why? That is the next part of the question.
You can argue about that. I would say that I would I would say that the first dinosaur that was mounted, Barapasaurus, you know, uh, would be the most significant find, because that was the most difficult thing to do. Whenever you are pioneering something, that's very difficult, and the workers there were able to do that and then mount the skeleton by 1972, which was, I think, the anniversary year of Guru Rabindranath Tagore. So that's why it's called Parapasaurus tagorei. So for me, I would think that that would be the start of this, that started the ball rolling, the dinosaur ball rolling.
Thank you, sir. There is another question by Manali. And the question is, I have always been fascinated by dinosaurs and have always wondered which modern day reptiles come closest to dinosaurs in the process of evolution. In fact, I
All the
am
birds,
very enthusiastic to
all the
know.
birds, all the birds actually glorify dinosaurs. And so if you're not happy with birds, then the next relative is the crocodiles. But all the birds are actually flying dinosaurs.
So, are lizards also the next generations of dinosaurs?
Which what?
Lizards, lizards.
lizard.
Lizard? No, no, they're different.
Okay.
Lizards are different.
Okay,
Yeah.
thank you, sir. I have two questions. The first one is, what were the social and survival behaviors of dinosaurs, and how would they likely react, hypothetically, of course, to humans in today's world if they existed today? It's
So they're like any reptiles. They were good when it came to family, and very aggressive when it was anybody that tried to attack, the family. but just like any reptiles. But after that, they lost control over what the family is, and so they would. So it is. There could have been cannibalism, but uh, well, it's like any. I think crocodiles would be a good model, good model. You know, to if you want to decipher the social behavior, maybe crocodiles would be one way of looking at it. They're like
So,
they're aggressive when it comes to obviously when it comes to feeding and other things, just like just like it happens in nature today.
And possibly territorial too.
Yes, yes, absolutely, absolutely. At least the predators are. So if you look at the predators today are more territorial than the herbivores. The herbivores basically are constrained by grasslands or browsing areas. So that's a different kind of behavior because of the food that they're eating. But there's the the predators are of course much fewer in number compared to the herbivores, and they are territorial.
Thank you, sir.
sir, there is another doubt or a question. The question is, were dinosaurs monopolic animals, or uh, did they had a single partner throughout their lifetime, or multiple
No,
uh, partners?
that's not possible to tell.
Okay,
That's not possible
thank
to
you,
tell.
sir. Thank you so much. It was just a curiosity.
No, it's
So
not possible to tell because you
yeah,
don't have a life history of a single family, or partners.
yes,
But I showed you uh, footprints, didn't I? I showed
yes,
you that they were walking together. So
yes,
if they
sir.
were walking together, uh, maybe they had better feelings as well.
That could be also possible. Yes,
But I think if we go by the behavior of reptiles today, most are food motivated more than anything else.
We are also food motivated. Who is not food motivated?
Yes, sir. But I don't know whether they would be capable of higher feelings. Although
No, no,
it can be.
higher feelings is a question of definition. Na? Yeah. So so they were more concerned with living, and surviving. Higher feelings come when everything is fine. Then you can, do other things, give in to what you call as higher feelings. It's difficult to survive in a jungle. So
Absolutely.
survival is the main focus.
Yes, sir. Based on instincts, they live their lives based
Yes,
on instinct.
exactly. Higher feelings comes when everything is fine.
Yes. Thank you. Thank you so much, sir.
it was really a very wonderful session, sir. And we lived our childhood again and now both. We have seen Jurassic Park in our childhood, and currently also, whenever we get time, we rewatch it. So this was really wonderful lecture, and it revived our memories. Now I request
Uh,
Shastri ji. Yes,
yeah,
Pranali,
and
you were going to add on
for that,
something.
not just a fascinating subject or something from our childhoods, but also a very important part of history because
True.
we know that we have such finds in our country and that there are such studies being undertaken. So it is also part of the historical narrative. So thank you for
Very.
this.
So
Uh,
now we have come to the end of the session, and I request Nandan Shastri ji, who is eagerly, very much interested to summarize the session and propose the vote of thanks. Over to you, sir.
Before I propose vote of thanks, sir, let me tell you, uh, my guru in paleontology was the late Professor Shingarpure from Maharaja Sayajirao University of Baroda, and my one former classmate, also famous paleontologist, Dr. Z.G. Gavaria, who was a director of a Gujarat Circle of a Geological Survey of India.
Yeah,
And
I know them well.
and when I was working in Division of Minerals, Gems, and Meteorites in American Museum of Natural History, every day we have to pass by the dinosaurs exhibit before arriving at our office. That is how my interest in paleontology 2004. And at Balasinor site, I was interviewed by two TV channels. School children found these telecasts so important that upon the request by various schools, the TV channel retelecasted the interview 5 times. So the slides which you showed, very super duper, and we had a very good glimpse of Indian dinosaurs. And uh, one of the theories of extinction of dinosaurs, perhaps, is the brain of dinosaur was not that much developed. So the other predators, small animals who used to try to harm dinosaurs, the signals were not reaching quickly to the brain of the dinosaurs. That is what we have been taught during our master degree program uh, in the university. And the question answer session was also very fruitful, and the attendees also uh, took part in question answer session, and the women's college, which has corroborated, there are many participants from that college also who have attended our today's lecture. So thank you very much to you, sir, and to all.
Thank you. Thank you.
Thank you very much. Before before saying goodbye for this session, I would like to inform that we have another session lined up today in this international webinar. It is in the evening at 6 o'clock. Is it 6 or 6:30, Nidhi?
5:30 it is. So
Oh, sorry.
yeah.
Okay, 5:30. At 5:30 today evening, by Dr. Rajiv Nigam. He's going to speak on foraminifera. So let us all join back today at 5:30 and listen with the same enthusiasm that we have shown in this session. Thank you. We are saying goodbye here. Thank you,
Goodbye.
sir.
Thank you. Thank you very much
Thank
for
you.
Thank you, sir.
listening.
Thank
Thank
you.
you.